Yo, what's up, guys? Linear algebra. We're starting the flashcard. Flashcards with Anki. We're gonna have at least 16 of them due. All right, we got 18 of them due. All right. If a linear system has infinitely many solutions, what is a general solution of that system? Basically, it's a set of parametric equations that generally defines all possible solutions. Set of parametric equations from which all solutions can be obtained by assigning numeric values to the parameters. We'll say again. What are the pivot positions of a matrix? These are the locations of leading ones in the row echelon forms of the augmented matrix. The positions of the leading ones in the row echelon forms. Good. What are the non-trivial solutions, if any, of a homogeneous linear system in the unknowns x1, x2, xn? What are the non-trivial solutions? Basically where these unknowns do not all equal 0. Any solution that is not the trivial solution. I think that's pretty good. How many solutions does a homogeneous linear system with more unknowns than equations have? How many solutions? More unknowns than equations? Huh? Oh, homogeneous. That means infinitely many. What are the leading variables in a linear system? Leading variables are basically the variables associated with leading ones from the row echelon forms of the matrix. Variables associated with leading ones in the row echelon forms of the augmented matrix. What is the definition of a matrix? So this is a rectangular array of numbers. What is the forward phase of the algorithm for solving a linear system by Gauss-Jordan elimination? So this forward phase is eliminating basically the numbers below the leading ones. Can we re-see that? The part of Gauss-Jordan elimination which the zeros are introduced below the leading ones. I'll say hard. What, because I said deleting the numbers, should be introducing zeros. What four properties must a matrix have to be in reduced row echelon form? Basically, rows that all only contain zeros are grouped together at the bottom of the matrix. Groups that do not only contain zeros begin with a 1 when reading from left to right. Two consecutive rows that are not all zeros. Basically, the row on top has the leading one that's further to the left, and then that's for all rows. And then columns that contain leading ones. So these pivot columns, they contain zeros and the leading one, and that's it. Okay, good. What is the trivial solution of a homogeneous linear system in the unknowns x1, x2, xn? The trivial solution is basically they all equal 0. x1 equals 0, x2 equals 0, xn equals 0. Cool. What is a homogeneous linear system? It's a linear system in which all the equations in the system have a constant equal to 0. Cool. What is a pivot column in a matrix? It's a column that contains a pivot position. What is the backward phase of the algorithm for solving linear systems by Gauss-Jordan elimination? Backward phase is introducing zeros above the leading ones. Okay. What are the numbers in a matrix called? Entries. What is the difference between Gaussian elimination and Gauss-Jordan elimination? There was something simple here. Right, Gaussian elimination gets the matrix into row echelon form. Gauss-Jordan gets the matrix into reduced row echelon form. If a matrix is in reduced row echelon form, what must be true of the first non-zero number in a row that does not consist entirely of zeros? It's got to be a 1. What 3 properties of a matrix must a matrix have to be in row echelon form? Okay, rows that are all zeros are grouped at the bottom of the matrix. Groups that contain numbers other than all zeros, these must begin with a 1 when reading from left to right, and then 2 consecutive or successive rows that are not all zeros. The row on top must have the leading one that's further to the left. That's true for all non-zero rows. Cool. If a homogeneous linear system has n unknowns and if the reduced row echelon form of augmented matrix has R0 or R non-zero rows, what can be said about the number of free variables of the system? The number of free variables is going to equal basically n minus r. What are the free variables in a linear system? These are variables that are not associated with the leading variables or leading ones. Variables that aren't associated with leading ones. In the row echelon forms, well, that's fine. That's a little redundant because the leading ones are part of row echelon form. That's it. Or row echelon form, so it looks like it's good. If a linear system has infinitely many solutions, what is a general solution of that system? Oh, this is a solution. It's basically a set of parametric equations in which the solutions can be, all the solutions can be found by plugging in numbers for the parameters. Okay, so that's good. All right, so that's Anki for the day. That took a while. Now, what we're gonna do, did we read anything new yesterday? Yes, we did. We read that matrix size is basically defined by rows by columns. And yeah, you say rows and then columns. So row X column is how you define the size of a variable. That's all we read about yesterday. So what I'm gonna do is continue reading today, and then I'll be back to recall in a bit. All right, guys, lots to unpack here. Basically, we finished up the section on matrix notation and terminology. Yeah, so let's just recall everything I can. Matrices are the same size. No. Matrices are equal if they're the same size and their corresponding entries are equal. Okay? We get a definition of a row vector, also known as a row matrix. This is a matrix that only has one row. We also got the definition of a column vector or a column matrix. This is a matrix with one column. These are special types of matrices and are denoted rather than with a capital letter. A matrix is typically denoted with a capital letter unless it's a vector, a row vector, or a column vector. These are denoted with lowercase bold letters. The entries, the numerical quantities of the entries are known as scalars, and these scalars are denoted with lowercase letters. Then we started talking about notation, matrix notation. So there's like well, first of all, there's one other note. 1x1 matrices do not have brackets typically, which makes it, you need to know like the context to know if it's a matrix or not. We got compact notation of a matrix is basically like a 1x1, it seems. It's got the matrix symbol equals compact or 1x1 row or 1x1 matrix with the entry and ij, and then sometimes mxn. I believe this is kind of like you're defining an entry potentially. So you're saying like the matrix, this matrix A at entry IA equals IJ. I don't know. It's still like abstract to me. MN is the rows times columns. I is denoting rows. J is denoting columns. I understand the basics of the notation. Basically, like say A12 is the entry at row 1, column 2. And there's a way to notate this. Basically, I think you use parentheses around the matrix symbol. So parentheses around a capital A, say, equals, or parentheses around A, IJ. So you define the location, and then you can basically say the number. Compact form's a little more confusing to me. Compact notation, I guess compact notation is not really defining a specific matrix. It's defining like a general matrix, it seems. Anyway, so I got those. I got the decent idea of the notation there. Then we already talked about matrices being equal. I think that's essentially everything, except for we started the next section titled Matrix Operations. And yeah, so this is going to be a section about the arithmetic of matrix arithmetic, so addition, subtraction, and multiplication. So far we've read about addition and subtraction, and basically it's like, from my understanding, the matrix sizes need to be equal. Okay, once you have two matrices that are equal size, you can add or subtract them, and basically you're just going to add and subtract the corresponding positions with each other, entries. So if you have a matrix A and a matrix B, and you have you're adding them, you're going to take A11 and add it to B11. You're going to take A12, add it to B12. You're going to take A13, add it to B13, all the way to AN. AN1. Yeah, because this is column 1. This is going to be A11, A21, AN1. Then going across, it's going to be A11, A21, AN1. That's what we already said, A1N, I mean. But you're going to add the corresponding entries. Okay? So pretty simple, right? A square matrix of something n, value n. Square matrix of order n, basically where n is the row and column size. So square matrix of order n is going to be n by n, and the line defined by, or like the segment of numbers or entries defined by A11, A22, ANN. This is called the main diagonal that goes across, splits the square. All right. And also, when we denote matrices and entries, we often use the same letters. So capital A for the matrix, then we're going to use the entries, we're going to use lowercase a. If we're using matrix F, capital F, well, then the entries are going to be lowercase f. So that's basically it, I believe, for today. Yeah. So now we got a decent understanding of matrix notation terminology. Now we're into matrix arithmetic, learning to add and subtract. But yeah. So that's going to wrap it up for today. I'll talk to you guys later. See ya.